Welcome to Demystifying Math. In this lesson, we're going to be graphing polynomial equations. A polynomial is a function that has whole numbers as exponents. To graph a polynomial, you want to find the zeros of the polynomial. That is, you want to find all the x-intercepts. You can do this by factoring the polynomial or by using synthetic division to help you factor. For a polynomial of degree n, you're going to have at most n zeros for the graph. You could have less, but you can't have more than n. We're also going to find the y-intercept by evaluating the function at 0. And for this lesson, we're going to find the turning points of the graph by using the graphing calculator. You will have at most n minus 1 turning points. And then you're going to indicate the end behavior of the graph by using arrowheads. We're going to look at the function f of x equals x to the third minus 13x plus 12. We're going to use synthetic division to factor the polynomial. If you're using synthetic division, then you need to know what your rational zeros theorem is. The rational zero theorem says that all the possible rational zeros are factors of the constant, which in this case is 12, divided by the leading coefficient, which in this case is 1. So we're looking for factors of 12. And we can use plus or minus 1, 2, 3, 4, 6, or 12. We're going to start by trying to find out if 1 is a rational zero for this function. So we're going to use synthetic division to divide a 1 into the function. So what I did here was I rewrote the polynomial without any variables. So this is 1x to the third, 0x squared. So if you're missing a term, you got to put in a 0. Negative 13x plus 12. And we're going to divide the 1 into it. So we're going to bring down this first one and then multiply the 1 times 1 and put it in this second position here. Then we're adding down and we have 1. And again, multiplying 1 times 1 gives me 1. And adding down, I get negative 12. So then I'm going to take negative 12 times the 1 and put it here and add down. Now, if my remainder is 0, then what I divided into the function is going to be a 0 of the function. So this tells me that 1 is a 0. If 1 is a 0, then x minus 1 must be a factor of f of x. The remaining factor comes from the remainder here that we have at the bottom of our synthetic division. So this number is always going to be 1 degree less than what we had divided into. So since we divided into a cubic, this is going to be a square term. So you have x squared plus x minus 12. Now that is factorable, so we want to go ahead and factor that. We could use synthetic division to factor again if we wanted to, but this one was pretty easy to factor without it. So we have x plus 4 times x minus 3 as the other two factors of f of x. So now we put it all together. We have f of x equals x minus 1 times x plus 4 times x minus 3, which means that we have 3 zeros at 1, negative 4, and 3. So those will be our 3 x-intercepts. Now we will try to find the y-intercept. The y-intercept is going to be whenever your x value is 0. So we're going to evaluate the function at 0. And we get out 12. So that means that 0, 12 is our y-intercept. Now we're going to look at the end behavior for the graph. For all polynomials, if the leading coefficient is positive, the graph heads up on the right. If the leading coefficient is negative, the graph heads down on the right. If the degree of the polynomial is even, the graph heads in the same direction on both ends. If the degree of the polynomial is odd, the graph heads in opposite directions on the ends. Now we're talking about the graph heading up on the right for the first one. That means from the rightmost 0, the graph is going to continue to head upward. Now on the other side, in this case we have an odd polynomial. From the leftmost 0, the graph is going to continue to head down on the left. Okay, so we have a positive leading coefficient and an odd polynomial. Now, between your x-intercepts, there are high points or low points, which we call maximums or minimums. And we're going to use a graphing calculator to find those. So each of your calculators probably work a little different, but find out how you can figure them out on there. If you're using calculus, the x values were plus or minus square root of 13 over 3, which I estimated on my calculator as negative 2.08 and 2.08. And then plugging that back into the f of x function, we get the ordered pairs. So I had a relative maximum point at negative 2.08 and 30.04, and the relative minimum point at 2.08 and negative 6.04. Now we're going to plot all the points that we found and connect them with a smooth curve. So notice that the end behavior, starting at the rightmost 0, the graph goes upward, and from the leftmost 0, the graph goes down. So again, this was odd, so it goes up on one side, down on the other. Then I plotted my relative maximum points, and a maximum point rather, and minimum point. And I have my 3 zeros plotted and my y-intercept. So that's your entire graph for this polynomial function. Thank you for tuning in to Demystifying Math.